Around 14 billion years ago, our entire universe was very, very small. How small? Well, it was roughly 1,000,000,000,000,000 times smaller than a single atom. Sounds like not much room for all the planets, stars, and galaxies that form our universe today. In fact, way before stars formed, the universe was a kind of soup containing an insane amount of energy crammed into that super tiny space. Sounds like a recipe for disaster. Not so much a disaster, but a cataclysmic event did happen indeed, causing a phenomenal expansion of the universe, cooling down its soup of energy, enough to form stars, then planets, including Earth, then all the creatures that live on it. That cataclysmic event is commonly known as the Big Bang. My name is Danny, I'm 9 years old from Australia, and I welcome you to episode 5 of Danny Decode, a podcast that explains what is hard to explain. Danny Decode. When you hear the words Big Bang, you might think of a huge explosion. But the Big Bang is not an explosion, but rather an expansion of space. Let me explain. There are 4 main forces in nature: gravitation, electromagnetism, the weak force, and the strong force. By the way, the weak force and the strong force have nothing to do with becoming a Jedi or mastering a lightsaber. They are actually forces playing an important role inside atoms. During the very first moments after the Big Bang, all these forces were still rolled into just one. Then the universe went through many phases, and the main forces were broken apart one by one, causing a tremendous expansion of space itself. All this happened very fast. In fact, when the universe was just 1 second old, it already reached a size of a few light years. If the Big Bang was an explosion spreading matter around, matter would have travelled faster than the speed of light, which we all know is not possible. Truth is, space itself was expanding, making the gaps between particles expand very fast in all directions. When all 4 main forces broke apart, they started to shape the universe. At that point in time, the universe was still hot and crammed full of all sorts of particles that began to form as the universe cooled down. These particles are the ingredients of all matter as we know it, and the recipe is quite easy. First you mix quarks and leptons together to form protons and neutrons, then keep cooling them down enough for electrons to stay around and help form atoms. These are the building blocks of stars, planets, people, and everything else. See? That was easy. The reality is that many of the heavier atoms, like oxygen or carbon, essential for life to exist, did not form directly from the initial soup of energy. Only simple atoms formed then, like hydrogen and helium. The first stars had to burn hydrogen for a very long time, turning it into heavier atoms. Then die, explode, and spread across all its matter to form the next generations of stars, until our sun and our planet formed. No one knows for sure what happened before the Big Bang, but many theories have been proposed by scientists. What if this universe is one of many in a multiverse? What if it just happened because it did? Or what if everything is just a computer game made by super intelligent aliens? All these theories do not satisfy anybody, though they remind us that if we knew everything, no one would have great questions to ask, and there certainly would be no scientists looking into them. As astrophysicist Neil deGrasse Tyson wrote in his book Astrophysics for Young People in a Hurry, I quote, "We are stardust brought to life, then empowered by the universe to figure itself out, and we have only just begun." Thank you, Neil deGrasse Tyson, for your fantastic book. I had a great time reading it, and I cannot recommend it enough. And thank you all for listening to Danny Decode. You can find more of my episodes at dannydecode.com, where I try my best to explain what is hard to explain.